Legend has it that as a young boy, Rene Descartes wasn't a kid that was always the most healthy kid. In fact, he woke up many days sick and was allowed to stay in bed for hours and hours. One day while he was staying in bed, he was staring at the ceiling and looking up, he saw a spider or a fly kind of walking on the ceiling. And he began to think if there was a way. I don't know if he began to think if there's a way. I think he was just thinking there's got to be a way to map the path this fly or spider is taking. And so he used one of the corners of the ceiling to kind of start to develop a system that we use today to map pathways, locations within a grid system. What I have here is what we're going to be using a lot as we continue in our mathematical careers is this type of a grid system. And a lot of people refer to this as the Descartes grid system as well. So a grid system is basically where I have two crossing axes. The horizontal axis is labeled our x-axis. The vertical axis, we label that as our y-axis. And what this allows us to do is to map any particular location in terms of an ordered pair, in terms of an x location and a y location. This coordinate system, notice that it's broken up into 4 sections. And we call those sections quadrants, where the upper right is our first quadrant, and then it goes counterclockwise around to the second quadrant, third quadrant, and the fourth quadrant. Additionally, the center point where the two axes cross each other, we refer to as the origin, or the point 0 and 0. So what we're going to look at doing is, how do we start to map some ordered pairs? I have listed 6 different ordered pairs. Now, the reason why we call them ordered pairs is because the order matters. Each of these pairs represent a coordinate position within the Cartesian coordinate system. I know I called it the Descartes coordinate system earlier, but a lot of people also refer to it as the Cartesian, after Descartes, Cartesian coordinate system. So I have a point that's listed as point A. That point is described as -3 and 5. So somewhere on here is a place that we all can agree on is a point -3 and 5. The first value within the Cartesian coordinate system or within an ordered pair is our x value, the distance on the x-axis from the origin. So the -3, so I start at the origin, and on the x-axis, which is my horizontal axis, I go a distance of -3. So I'm going to back up to the -3 position. The second number or coordinate in the ordered pair is a 5. It's a positive 5, so positive means I'm going to go up, or in the vertical y direction, 5 units. So right there is the point A, which represents the point -3 and 5. B is 2 and -4. Notice that the x value is a positive 2 and the y value is a -4. So where those 2 points, or those 2 and the -4 cross each other, that's the point B. And that's in our fourth quadrant. Point A is in our second quadrant. C. Okay, that one's a little tricky, it looks like. I have a 5 and a 0. So what do we do? Well, 0 is still a value. It's still a distance related from the origin. So our first value is our x value, goes over to 5 units, and then that y value tells me my distance on the y-axis is 0. So I do not go up or down. I'm just right there on the x-axis. And so that's my point C. D, -5 and -2. Okay, x-axis, x value was again the first one in the ordered pair. So I go backwards horizontally in -5 and down in -2. And that's my point D. E starts off with a 0. So I do not travel any distance on the x-axis. I stay on the y-axis and I go up 4 units among the y-axis. So here's the point 0,4. And we're going to label that one E. And then lastly, point F is 0 and 0. That's right here at the origin. I go over 0, up 0. And so there's point F right there on the origin. Now, notice that I have points in different quadrants, but I also have points on the axis and there's points on the origin. All those are fine locations to have a coordinate pair. If I have a 0 in either the x or the y, I know for sure it's going to always be on one or both of the axes. So that's a little bit of a clue that we can help and go from there. Now, the reason why we're going to start to do this, and this is what Rene Descartes kind of helped us to begin, is this is a bridge between algebra and geometry. We are able to start to model some algebraic statements in a geometric fashion. And with that, we need to understand where are some coordinate points or coordinate pairs and how to map them and describe them.